import this one more time, and this time we're going to use page 9. Page 9 gives us the wall junction details. Let's drag this around. Going to scale this one differently this time. So let's explode it, because it's mostly based on all of the timber frame. So I want the timber frame to be the right size this time. So let's select it all, edit, reshape, resize. Before I can redo that, I need to make sure grouping is suspended. Edit, reshaping, resize, and zoom in and make this 90 millimeters, R90. There we go. This is currently where on our trace detail, so we're going to go to the general detail. Sorry, going to the bathroom detail. Show as trace reference, and then we can trace over this one. So with this one, which one are we using? I'll explain both of them. This one is created as water resistant by having an exterior angle. What this is talking about is that, again, it's most likely to fail. If it's going to fail anywhere, it'll fail in the corner where the tiles meet and where the billboard meets. So there's an exterior piece of plastic. We can do that option, or we can have an interior detail where we have our billboard on the outside, and then we're creating a waterproof layer on the internal face of the billboard, and then we're tiling over that one. I'm going to use the second option. That's my preferred method in terms of consistency with all the others, and to not need to use that piece of plastic. Of course, we could do both if we wanted to be incredibly thorough and have plastic behind the billboard, and then waterproof on the inside of it, but that's not required in terms of Australian standards. So this is the one that we're tracing. We want to be smart again as much as possible, so we're going to use the one that we've already created. So we can use either one of these. Move, drag a copy. I will rotate this so it's in the same sort of angle as we see here. And then we can just move things around to make this work the way that we want. So this is the type of stud size that we want to use. We'll see if it works. I'm again going to connect them perfectly, not do it the way this is created. So this type of wall frame isn't necessarily practical or correct. Let's instead move, we don't want a 90 by 90 block is effectively what I'm saying. So we're going to move this one 90 millimeters. And we're going to drag a copy of this one, rotate this. And we'll turn that one off for a second. Move that one there. So we're creating a corner. And then effectively we want this to continue this way. And in terms of a wall frame, what this means is that effectively this one here is done as one wall frame, and this one here is done as one wall frame. If we were to continue along in that direction, I'd probably flip this around. So this one here would be continuous, and this one here would not. If it was a corner, so I'm going to assume that it's a corner just to keep it simpler. This would possibly be the way. Again, it doesn't make a difference. So we could flip this one, we could mirror this one, mirror, and that would be exactly the same. There wouldn't be a difference to what we're trying to create. All right, then we're copying stuff. So we're going to take all of this, move, drag a copy, take it to the corner, move, mirror a copy. Again, it's much faster to do this once we've already got something to trace. And then all we need to do is to make this corner work. I'm going to go back to a really cool tool when you're trying to toggle between what you're seeing is to go switch reference with active. So what we're wanting to have here is flexible wet area sealant. So another word for that would be silicon. We want that to create a movement joint so that it won't crack. It doesn't really matter the orientation of this, of course. What's important is that we are fixing the villa board to the frame, and if the frame was to move and the villa board was to move, it's not going to create a crack. So we'll turn that back on, and now we'll go switch reference with active, back there. So which way do we want this to be? Let's, in this case, offset this, move that back 6 millimeters. And then we're creating, let's find where my grey fill is. We're wanting to have that filled with silicon. Let's connect these. Now we don't really have the luxury of creating this as a non-right angle because we need our tiles to fit together at right angles. We don't want to have a mitered or a chamfered edge. Now that's effectively what we're trying to do, and again we need to back that off, whatever our spacing is, in order to be able to have that as a joint. One more check, turn that on, switch, again, so we see that there's a silicon joint there. Let's just make this bigger, just so it's the same size. I'll do it in one go this time by using the stretch tool, edit, reshape, stretch, R3. That's it. Of course, we haven't added the annotations, but in terms of the drawings, that's what we're trying to create. Delete. So now we've created a few different floor-to-wall junctions, and these are, of course, are all based on timber frame. We could do the same with concrete next. We're creating a bathroom floor-to-hallway floor, and we're creating an internal wall junction. The next one we're going to do in the next video is an external wall junction, not meaning the exterior of the house, but if this is an internal corner, we're going to do an external corner, and what we need to do to finish that off.